So more factoring? Yep. We're going to be factoring for the rest of the school year, and I'm not kidding. So remember that we are in the world of quadratic functions, and a lot of people get confused as to what a quadratic function is. A quadratic function is another way of saying we have a second degree polynomial. Remember that a polynomial is multiple terms in the same expression. So if we have a quadratic function, in other words, a second degree polynomial, that means that the highest exponent we see for x is 2. There should only be x squared as the highest exponent, not x to the third, not x to the fourth, not x to the fifth, and so on and so forth. So x squared is the highest exponent that you will see for your variable. So a quadratic is a second degree polynomial. That's all it means. So without further ado, it's time I introduce to you a standard form of a quadratic function. In other words, what we're paying attention to is eventually you're going to get to some form of ax squared plus bx plus c. So in Algebra 2, this is what's called the standard form of a quadratic function. But remember, our goal is to factor into two binomials. Okay, so we have this ax squared plus bx plus c, and we want it, remember before it was like x plus 3 times x plus 7 or something crazy like that. But this time we're going to be putting coefficients in there. So 3x plus 5 times 7x minus 2, or something crazy like that. So we're going to factor. We want a multiplication problem. Spoiler alert, the zero product principle is coming back. Okay? So let's review how to FOIL. So just to get your feet wet, remember that we had x plus 8 times x plus 3, and we could do what's called the FOIL method. Well, x times x is x squared, and x times positive 3 is positive 3x. 8 times x is positive 8x. And then 8 times 3 is positive 24. Then I could combine the like terms in the middle. That'd be x squared plus 11x plus 24, which is what we're used to. And hey, it's in standard form. We get x squared plus 11x plus 24, and there was no number in front of x squared, so the coefficient is 1. So technically, it is in standard form. Okay? So let's do number 2. A little bit different, but we're not that afraid of it. So let's do FOIL, or if you prefer the rectangle, go for it. Remember that rectangular area model where we drew it like this? 3x plus 2 times 2x plus 1. If you like drawing it like this, be my guest. 2x times 3x is 6x squared. 2x times 2 is positive 4x. 3x times 1 is positive 3x. And 1 times 2 is positive 2. Okay, so the rectangle is going to come back and help us. But for now, if you like the FOIL method, 3x times 2x is 6x squared. 3x times 1 is positive 3x. 2 times 2x is positive 4x. And 2 times 1 is positive 2. Okay, so therefore, I can combine the like terms in the middle and get you 3x plus 4x, making it 7x. So 6x squared plus 7x plus 2. And it's in standard form because we have 6x squared plus 7x plus 2. A is 6, B is 7, and C is 2. I forgot to put that up here. A is 1, B is 11, and C is 24. You don't have to put this part for the review, but I'm just updating you that this is basically what we're doing. Is we're labeling our A, B, and C, and we want to get it into factored form. All right, let's do number 3. Remember, we can do the rectangle or the FOIL way, but I'm just going to do FOIL just because I want to get you guys a lot of practice with what we're doing. So we've got 7x times 1x. 7 times 1 is 7, and x times x is x squared. Therefore, 7x times 1x is 7x squared. 7x times positive 2 is 14x. Sorry about that, I didn't put the arrow. So 7x times 2 is positive 14x. 1 times x is positive 1x. And then 1 times 2 is positive 2. Okay, I'm going to combine the like terms in the middle. And that gets me 7x squared plus 15x plus 2. And that's what we wanted. So just a review. Remember, in this case, the A is 7, the B is 15, and the C is 2. Okay. Finally, for the final review problem, and then we'll get to some factoring today, is what happens? Well, we've got 3x plus 4 times 4x plus 5. So 3x times 4x is 12x squared. Sorry, I put a little arrow on top of the 4. That's a 3x and that's a 4x. 3x times 5 is positive 15x. 4 times 4x is 16x, positive 16x, sorry. And 4 times 5 is positive 20. So I'm going to combine the like terms in the middle. And that's going to get me 12x squared plus 31x plus 20. I'm going to box it, and I'm just going to make a little note to myself that the A is 12, the B is 31, and the C is 20. Okay. All right. Now, why did I go over this? Because our goal is to get from here back to the factored form, here to the factored form. Sorry about that. So the black boxed answers, we're going to go back to the multiplication problem. You know the answers ahead of time, so please keep that in mind. I'm going to show you step by step how to do that so you ease your anxiety. So before, the previous test was still on factoring quadratic trinomials, and I was going to put step by step, but then the strategy, it's more of a strategy than a step by step. So in this case, you had x squared plus bx plus c. So even though it's standard form, it's a equals 1. So when you did that for the previous test, what you did was you found the two whole numbers that multiplied to c and added to b. And once you did that, you split it into two binomials, and it was just, those are the good old days. I'm not going to lie. Those were the good old days. Now, what happens when you factor a quadratic trinomial where there's going to be a number in front of x squared that you can't factor out? So remember on the previous test, when there was a number in front of x squared, I was a very nice guy. I let you guys factor out the GCF. Now I've got ax squared plus bx plus c, where the a in front is not only not equal to 1, but I can't factor it out from b and c. Step 1. So write down the steps, and we're going to do the same thing for 3 problems today. So this is the strategy. So instead of finding out the two numbers that multiplied to c, what we've been doing all along was finding the two whole numbers that multiplied to ac and added to b. Like literally multiply a times c, whatever that is, and find those two whole numbers that add to b. Okay? Step 2, you split the you split the middle term with the winning team, and I'll explain what that means. And then step number 3, factor by rectangle. Okay? So I'm going to hold it here for about another 30 seconds or so. And I guess the reason why I was so passionate about this, I've gotten 2 emails so far saying, "What happened to the stories? What I missed your stories that related to this class." So, for those of you who want a story, here it goes. Believe it or not, so when I was in 8th grade, they had this radical idea of trying to implement Algebra 1 into 8th grade. And this was back in 2002. Now it's so commonplace, but back in the early 2000s, that was a scary idea to put high school level material in 8th grade. So when I was in 7th grade, they put me in a placement test to see could I go into Algebra 1 in 8th grade, or should I just take standard 8th grade math in 8th grade? Well, I took the test and I barely passed into the Algebra 1 portion, so I felt like a success. But truth be told, I wasn't fully prepared for it. I did really well on the solve for x part, but for some reason, quadratic trinomials bugged me. In fact, elimination method, substitution method, the first time I saw that bugged me. Remember that one when you figured out when 2 lines intersected? I hate to ramble on and on, but the point is, when I took Algebra 1 in 8th grade, so back in 2002, factoring quadratic trinomials was a nightmare for me because the way my teacher taught it was guess and check. Just guess and you'll get the right answer. And I mean it. I was like, that was the technique, just guess and check. So even though I managed to get really good at the guess and check method eventually, and I mean 11th grade, I did really well in 9th grade, but it was just guess and check. And then 11th grade, I was like, okay, I really got this now because I took Algebra 2. But the point is, when I graduated high school in 2006, and then I went to college, and then around 2010-ish, I was a TA for summer school in Algebra 1, and I did that for 4 summers. My second summer being the TA, and I was tutoring this for the Algebra 1, and I was teaching with the guess and check way. I was a TA, so in other words, there was a teacher above me who did the lecture, and I just did some tutoring to help strengthen their learning. Well, the second summer, I had a really good teacher from China, and he said that this is the way that they teach us. And it turns out it's not necessarily the Chinese way, but just that they strengthen it with FOIL connecting to this. They're not separate. So anyway, let's get on with the 3 problems. The point is, this is the method that I learned that I feel is the best way to teach factoring quadratic trinomials. Okay, so for instance, problem number 1. Again, these are the expanded versions of the problems that we multiplied. So I want to factor 6x squared plus 7x plus 2 into 2 binomials. So let's take a deep breath. This might hurt. Okay, so step 1, I'm here to help you. I would label my A, B, and C. So this is in standard form. AX squared plus BX plus C. So my A is 6, my B is 7, and my C is 2. Okay? Step 1, once you've done the A, B, and C, it just makes me calm. So I'm trying to figure out what 2 numbers multiply to A times C and add to B. Well, remember that A times C, positive 6 times positive 2, that'd be positive 12. So 2 numbers that multiply to AC, positive 12, 6 times 2, and add to positive 7. Now, if you're really, really good at this, awesome. I'm really happy. So we run through the list of suspects. 1 and 12. 1 times 12 is 12. 1 plus 12 is 13. 2 times 6. 2 times 6 is 12. 2 plus 6 is 8. That's not what I want. Let's try 3 times 4. 3 times 4 is 12. 3 plus 4 is 7. Ah, there's the winning team. So I know what you're thinking. Do we go into x plus... Let me get a pencil just to show you. Now I'm going to erase it really quick. Come on. There we go. So a lot of mistakes that I see, and this is a big mistake, don't copy this part down, is they go x plus 3 times x plus 4. No, there's a 6 in front of there. If I did x times x, it'd be x squared, not 6x squared. So please don't do this, okay? You found the winning team, okay? So then you split the middle term. And what do I mean by this? It turns out that the 3 and 4, the winning team that multiplied to AC and added to B, are very, very useful, because what that does is I take the middle term, 7x. So now the middle term can be split into positive 3x and positive 7x. Okay? So now this expression becomes 6x squared plus 3x plus 7x plus 2. Now we're getting somewhere. Okay. So factor by rectangle. What does that mean? Okay, so this is the method that my 2011 summer school boss showed me, and I thought this was the coolest thing. 6x squared goes in the top left. Positive 2 goes in the bottom right. And the split bx's, so what makes up positive 7x, is split into these two. It doesn't matter if you put 3x here or 3x here. So let's just put positive 3x here and positive 7x here. So take a deep breath. And then if we were teaching in class, I would have a little fun. I would get I would get one of my baseball bobbleheads or basketball bobbleheads. Because what I do is I cover the right column. What is the GCF of 6x squared and 3x? In other words, what is the biggest term I can divide out of 6x squared and 3x? So the GCF of 6x squared and 3x is, in fact, 3x. Let me cover it up really quick. Because the biggest number I can divide out of 6 and 3 is 3, and the biggest number I can divide out of x squared and x is x. So 3x I'm going to take out. Now the other three pieces are going to fall like dominoes. 3x times what is 6x squared? (2x). 3x times what is positive 3x? Well, 3 times 1 is 3, so 3x times positive 1 is 3x. Now, 2x times what is 7? Wait, hold on. Did I mess this up? Oh, 4x. Sorry about that. I am so sorry. I am so sorry. That's a 4x. I apologize. I sincerely apologize. That's a positive 4x. I sincerely apologize. Okay, sorry, just to backtrack a little bit. 6x squared plus 7x plus 2 splits into the winning team of 3x and 4x. Positive 3x, positive 4x. Okay, what can I take out? 6x squared and 3x, I can take out a 3x. Okay, 3x times 2x is 6x squared. 3x times 1 is 3x. I'm sorry. Then 2x times what is positive 4x? Positive 2. And just to check your work, 1 times 2 is 2. Therefore, what does this factor into? This factors into 3x plus 2 times 2x plus 1. And you can check your work by FOILing it out. So that is how you factor a quadratic trinomial where a is not 1. Okay? All right, let's see if we can do this problem number 2 a little bit slower so that we don't mess up. Okay, so I want to factor completely 7x squared plus 15x plus 2. Well, what I'm going to do is I'm going to label my A, my B, and my C. My A is 7, my B is 15, and my C is 2. So I'm looking for two numbers that multiply to AC and add to B. So in this case, 7 times 2, A times C, would be positive 14. And then my B is positive 15. Huh. What two numbers multiply to 14 and add to 15? One times 14 is 14. 1 plus 14 is 15. We got it on the first try. I love it when we get it on the first try. Always write out the first case. Even if you're unsure it works sometimes. So what do we do with that winning team? Now I'm going to take a deep breath so I don't mess up again. So I've got 7x squared plus 15x plus 2. So why is the winning team so important? Because it splits the middle term. So I'm going to split the middle term into positive 1x and positive 14x. So 7x squared plus 1x plus 14x plus 2. And now I'm going to put all the pieces in the rectangle. Factor by rectangle. It's awesome. So now I'm going to put the big fella, 7x squared, in the top left. Okay? And then positive 2 in the bottom right. And it doesn't matter which one goes which. So I'll put positive 1x here and positive 14x here. Okay? Now I'm going to try to figure out what these four pieces are in the rectangle. I'm going to cover up the right column. What can I take out of 7x squared and positive 1x? Well, the GCF of 7 and 1 is 1, so that doesn't really help me. But the biggest number I can take out of x squared and x is just x. So if I factor out an x from 7x squared and positive 1x, now I'm in business. The rest of the remaining three pieces are going to fall like dominoes. So x times what is 7x squared? (7x). X times what is positive 1x? Positive 1. 7x times what is positive 14x? Positive 2. 7x times 2 is 14x. Check your work. Is 1 times 2, 2? Yes. So therefore, I can factor this whole thing into 7x plus 1 times x plus 2. And that's how I get my solution. That's how I factor this quadratic trinomial. Okay. Last problem. Okay. This is a big one just to show you that some of these take a little bit of work. Okay. So once again, I want to break this down into a multiplication problem where A is 12, B is 31, and C is 20. So I'm looking for the two whole numbers that multiply to A times C and add to B. 12 times 20 is positive 140, and B is 31. I don't know this off the top of my head. I made a table, and let's find out. Well, let's list out the suspects. Even if it doesn't work, it doesn't hurt to try. 240, sorry. 240. Even worse, two numbers that multiply to 240 and add to 31. Well, 1 times 240 is not going to work. But just because I put it up there doesn't mean it doesn't mean it'll stimulate my brain to keep going. 1 times 240 is 240. 1 plus 240 is positive 241. Okay. 2 times what is 240? That'd be 120. 2 times 120 is 240. 2 plus 120 is 122. 3 times something is 240. So 240 divided by 3, that would be 80. 3 plus 80 is 83. Okay. 4 goes into 240 60 times. 4 times 60 is 240. 4 plus 60 is Nintendo 64. But notice we're getting closer and closer to 31. All right. 5 goes into 240 48 times. I got a calculator. I did this ahead of time. 5 times 48 is 240. 5 plus 48 is 53. Closer to 31 I go. 6 goes into 240 40 times. 6 times 40 is 240. 6 plus 40 is 46. 240 divided by 7 got me a decimal, so forget about it. But 240 divided by 8 is 30. So 8 times 30 is 240. 8 plus 30 is 38. Closer to 31 we go. All right. 240 divided by 9 got me a decimal. 240 divided by 10, well, it ends in a 0, so I'll go 10 times 24. 10 plus 24 is 34. Oh, so close to 31. All right, well, 240 divided by 11 got me a decimal. 240 divided by 12 got me 20. So 12 times 20 is 240. 12 plus 20 is 32. Come on. 240 divided by 13, decimal. 240 divided by 14, decimal. 240 divided by 15 is 16. 15 times 16 is 240. 15 plus 16 is 31. Finally, we got the winning team. Is the problem done? Is the problem done? No, I gotta split the middle term. Come on. So in particular, that 15 and 16 is going to help us split the middle term. It's going to take the positive 31x and make it into positive 15x and positive 16x. Okay? Even though it's ridiculous, I'm glad to be in business. Okay? So now we're going to go to the last step. We've got 12x squared in the big spot. We've got positive 20 in the top and in the bottom right corner, and it doesn't matter. I like to put positive 15x here, and I'm going to put positive 16x here. It doesn't matter which one goes which because you're still going to factor out. Okay, so I'm going to cover the right column. What is the biggest number I can factor out of 12x squared and 15x? That would be 3x, because the biggest number I could divide out of 12 and 15, get a whole number, is 3, and x squared and x can both factor out in x. Now the other three pieces are going to fall just like dominoes. 3x times what is 12x squared? (4x). 3x times what is 15x? Positive 5. 4x times what is 16x? Positive 4. And check your work. 5 times 4 is 20? You betcha. So to the final answer of this is we can factor this whole thing into 4x plus 5 times 3x plus 4. Boom. And just to show you, let's go back to the 3 problems that we did. We got 6x squared plus 7x plus 2 could be factored into 3x plus 2 times 2x plus 1. We got 7x squared plus 15x plus 2 could be factored into 7x plus 1 times x plus 2. And finally, 12x squared plus 31x plus 20 could be factored into 3x plus 4 times 4x plus 5. Looks good to me. Again, I don't expect you guys to be a master at this in one day, so please embrace the process. It's literally multiply to AC and add to B, split the middle term, and factor by rectangle. Have a good day.